Hey guys, welcome to the Tech Granth. Today I am going to follow up my previous video on the tutorial of linked list with some hands-on session. Do like and share the video, subscribe to the channel to get further updates. Um I will be putting all these codes on GitHub, so the link for that is there in the description. I've also solved multiple lead code problems, which is also there on GitHub. For each of them, the video is also available on my channel, so do check that out. So let us try to some, and I'm going to use Java to show some hands-on problem on linked list. You can basically use any programming language. The concept will remain same, and only the programming language nuance will change. So that should be okay. So let us create a node. So like I explained in my previous video on linked list, everything in linked list is driven by a node. So a node in Java can be represented by a class. So the node class, like if this is a linked list where you have number like 3, a linked list of integer. So if it looks something like this, so each of these will be a node, each of these blocks will be a node, and node will have two properties like I explained. So the first one will be the value it contains. So since this contains integer, so this will be the first property, and the second property of the node will be where it is pointing to. So each node point to the next node in the list. So 4 points to 3, so that we can get it using a reference. So here if I create something like this, so it means that this node, when it gets initialized, it will have some value and a pointer which points to the next node. So if this node gets initialized by 4, so it will have a pointer, it will have a value as 4 and a pointer to the next node which is 3. So that is how it will work. So just let me change it to a class, and I'll create one more class here, and I will say linked list operations, and here we will try to initialize the node, create multiple node, add node one after the other, remove node, all those operations that are related to the linked list we will try to do it here. So let's start with some creation. So I'll just create an instance of this. These are like the basic Java operation where you create the instance of a class, an object of a class, and that will help you to call any method. If I add any method here, so it will help me to call that method. So if I create a method here which says add node, and this add node will get an integer value. So if suppose I have to create a node for number 4, so I will pass 4 here and it will create a node for me. Then if I have to add 3 here, then it should create a node 4 and then it should add 3 to it. So something like that. So here when I got the value, so I will do a check that and this should have a head node. So this head node will be nothing but the starting point of the linked list. So if this is like if the list is like 4 and 3, so head node should point to the value 4. So here we will do a check first if head is equals to null. So in that case what we'll do is we'll create a new node. So head is equals to new node, and we'll say head dot value is equals to whatever value we are getting from here. Okay, so this will create a new node, and it will name it as it will put the value as 4 there, or whatever value we are passing here. Now since I have not added anything in head dot next, so by default it will be null for now. So let us just see if this node got added or not. For that, what we will do is we'll simply print the linked list. So how you will print the linked list is you will just traverse through the list like I told initially. So we'll say while head is not equal to null, you traverse, you say system dot out dot println, and you say head dot value, and head is equals to head dot next. So till it is present, we will print the head, and here we have to call the add method. So I will say a dot add node, and I will pass the value 4, and once it is added, then I will say you print the list. So in this part of the program, it should add this node 4 and it should print the node 4. So let us run this. So if you see, it has printed 4, and just let me add something like this here. Every time it prints, I will add a pointer like this. It shows that it is pointing to the next one. So currently it will not be pointing to anything because 4 is the only node that is present. I have to add another node to this. Suppose I have to do something like this, where I have to add a new node of value 5 just before 4, or I have to add multiple nodes. See, I have to add like 2 before 5. If I have to create something like this, then what I need to do is I need to create this node first, and then I need to point that node to the next node or the existing head that is present. So how I will do that is I will say, okay, this part is done, so return from here, and now I'll create a temp node which is equals to the new node, and here I will say temp dot value, it is equals to the value. So this is where I created the new node. If 5 has come here, so by the time 5 came, this head is not equal to null because head is already pointing to the first node that we created, which is 4. So it will not go inside this, and it will come here, it will create a new node here, and it will assign the value 5 to it. Now this temp node that we have created, I have to point this to the next node, which is my head node. So what I will do is I will say temp dot next is equals to my head. So what this will do is I had 4 here, and I created a node 5. Initially it was pointing to nothing, but then when I said this temp dot next equal to head, it will start pointing here, but my head still is at 4. So when I do a print, let me print it, so it will print only 4 in this particular case. So let us print this once, and I'm sorry, we need to add that 5 as well, and I'll do a system dot out here just to show that the 5 got added here. So temp dot value, adding new node. Okay, so if I print this, it added the new node 5, but it is still starting from 4, and it did not show me whether the 5 got added or not. So for that, what I need to do is I just need to shift my head. I need to make my head as temp. So what will happen is when I had 4 here, I created a new node 5, I assigned 5 to it, and my head was here at 4, so I just moved my head back to 5. So now if I print this, it printed correctly like how we expected. If I have to add one more node here, say 2, so it printed like 254 like this. So it is creating that chain of linked list. Now the thing is, here you are seeing that every time I add a node, I am adding it in front of my previous node. So what if I have to add it to the end of the node? I'm adding it in the front because it is happening in a time complexity of order of 1, which is a constant time. because every time I'm getting a node, I'm just creating a new means every time I have to add a value to the linked list, I'm creating a new node and I'm assigning that node as the head, and all the everything will trail that. Now if I have to add it towards the end or in the middle, so what I have to do is I have to traverse the linked list, and then I need to basically then I need to uh, add the node. So if I have a linked list like this 2 4 5 4, and now I have to add something here, say 10. So in this case what I need to do is I need to traverse this whole list, and then I need to add this element. So let me show. So we'll create a new method for it. We'll say private void add node at end, and I will say int of value, and we will add this condition. This is like an edge case where if our head is not initialized yet or it is null, and we call this method. So for that particular purpose, otherwise we'll create a current node first and we'll assign a head to it, because why we want this is because we need to traverse this linked list from 254 till the end, so that after 4 we can add our current node, or we can add the new node whatever we are getting. If I have to add 10 after 4, so I need a pointer which can go till the end of the linked list, and this current node will be that pointer. So we'll say that okay, till we'll traverse the linked list till current dot next not equal to null is not equal to null. So we'll traverse till this particular point. I will start from 2. Since my head is at 2, I will say that okay, the 2 dot next is not equal to null. Then I'll go to 5. 5 dot next is not equal to null, so I will be at 4. So 4 dot next is equals to null, so I will come out of the loop, and I will make 4 dot next point to the new node that I'm going to add. So here I will say that okay, you just keep on moving till the next is not equal to null and current is equals to current dot next. So this means that I will move my current point. I will move my current node from the head, and I'll move the current node till I don't reach the last node that is present. So once I will reach the last node, at that point I will create my new node. I will say okay, new node is equals to new, and this new node dot value that we have, this new node dot value will be the value that we are getting here. So I have created my new node now, and I need the last node of the linked list to point to this new node. So here I will say that current dot next is equals to the new node. So now in this particular case my head is not changing, only thing is I traverse the whole list to add it in the end. So let us try to add. So a dot add the node in the end, and I will say add 10 to it, and we'll run the same program. So you see it added 10 after the 4. So this is how you add a node towards the end of the list. You have to delete a node now. So suppose you have to delete this first element 2 from here of this particular linked list. So what you will do is you will currently the head will be at 2, so you move your head to 5 and you break this pointer. So 2 to 5, the connection that happens, you break this connection, so 2 will be removed from this linked list. So programmatically how we'll do is we'll create a method here, remove first node, and when we do remove first node, we'll again create a current node. So all these current node we create because we don't want to disturb the head. We just want to when we iterate through the linked list, we need this pointer to be moved from the current position. So it will be pointing to head now, and we'll say head equal to head dot next. So now head will be moved from 2 to 5 because it will start pointing to this 5, and my current is still pointing to the old head, which is at 2. So I'll say current dot next is equals to null. So now this, when I say current dot next equal to null, so this 2 to 5 connection will be broken and my head is already shifted to 5. So my new linked list will start from 5 and it will go till 10. So let us run this and see if it works or if it is like how we are expecting it. So I will just say here system.out print ln and something like this, deleting node now, and I'll say a dot remove first node, and after that again print my linked list. So if I run this, so you see it printed the initial list, and I think there is a print, so there is no new line added, so it printed this here only, so that's fine. And after that it printed the new list after deleting this or after removing the first element. So if you see, it removed two from that particular or two from the starting position. So if I have to remove some other element, or if I have to remove suppose 4 from here, so in that case what we will do is we need to traverse this linked list till I get the value 4, and once I get the value 4 I need to move the pointer from 5 to 10. So let us give it a try. So I will say private void remove mid node, or let us say nth node, any nth node that so this value should be passed to us, and which value I have to delete. So in this case we need to keep a track of our previous node, because my current node will move from 5 to 4 if the current node matches the value. So in that case I have to move the previous node dot next to my current dot next. Let me explain that here. So if I have 5, 4 and 10, so I need two pointers here basically. One will be here, P is for previous node, and one will be C for current node. So previous node will point to the previous thing, initially it will be null. So initially it will be null, and current will point to the head of the linked list. So current will point here. Now current will move to 4. Since 4 matches the value, so I have to remove 4. But since I've already moved from 5 to 4, how I will be able to link 5 to 10? Because to remove 4, I have to break this connection between 5 and 4, and I have to connect 5 to 10 directly. So that is why I will require a previous node. So every time I move my current, I will assign the current value to my previous value. So what I will do is I will require a previous node which will be null initially. I will require a current node which will be equal to the head of the linked list, and I will say while current dot value is not equal to my value, I will move till that particular point, and every time I move I will assign the previous node to my current node. So when I move from 5 to 4, so my previous node will become 5 and my current node will become 4. So how current node will become 4 is I will say current equal to current dot next. So my current node has become this value now. It has become 4 now. So this is how these will be assigned, and once I come out of the loop where my current value matches the value 4 which I have to remove, so here I will say that okay, my previous node dot next, it should be equal to whatever my current dot next. So this means that this pointer will be broken, and this pointer is not yet broken, but this is pointing to 10 now, and I will say current dot next equal to null now. So this way my previous node will point to this particular node, and 4 will be gone from my list. So let us run this as well. I will say a dot remove nth node, and I need to remove this node 4, and I need to print this list again. So let us run this. Let us add one more line here, just for so that it does not print just after this. You see, now in this case 4 is gone, so 5 directly pointed to 10. So that is how we traverse this list, and we removed the element from middle. So these are the basic operations that you do with linked list. You add element in front, you add element in middle, or you add element towards the end. You remove element from the beginning, or you remove element from the end or from the middle. These kinds of operations are supported by linked list. After this, there will be some more complex questions that will be asked of linked list, like you need to get the sum of two linked list. I have already added a video for this that was part of the lead code problem that I solved, so you can visit that. I will add the link in the description. And you will also be given question like reverse a linked list. Uh, so those problems are like, if you are given a linked list like this, so it's 1 2 3 4, you need to reverse the linked list, and the output should be something like this. But behind all these things, the concept of the linked list will not change. It will be still the same. So you just need to see how the connection between the two nodes will be, and how you can break and reconnect. Like if you see, for reversal of the linked list, you can break all these connection. You can break the connection between 1 and 2, and let 2 connect to 1, 3 connect to 2, and 4 connect to 3, like that. So you can start thinking on that term. I will not be solving that problem as part of this video, or any other problem as part of this video, because it will become very long and boring. I will come up with more videos on linked list, where I will solve the problem that are related to linked list. But that is it for now in terms of linked list. Next, I will come up with a tutorial on stack, and then I will move on with the hands-on session of stack. Then we'll work with queues and trees and all the other data structures. So subscribe to the channel, keep a tab. I will come up with more contents. See you. Bye.